Assalamu alaikum, students and friends. Welcome to my video tutorial for physics students. In today's episode, I am discussing a displacement time graph focusing on finding the average velocity, the total distance traveled, and the net displacement of a particle in rectilinear motion. So just hang on, stick around, watch, and learn. Consider a particle in a straight line motion. Refer to the following displacement time graph. The question is, based on the given graph, what is the magnitude and direction of the average velocity during each segment A, B, C, and D? Find the total distance covered in 30 seconds. What is the net displacement of the particle at the end of 30 seconds? For question letter A, finding the average velocity during the time interval represented by each segment of the graph, we use the slope formula for a displacement time graph. Let's start with segment A. A straight line sloping upward to the right. That is how we describe the graph line represented by segment A. And so therefore, we can already predict that the magnitude of the average velocity is going to be a positive and constant average velocity. All right. So using the formula for determining the slope of a displacement time graph, which is simply delta d, or the change in displacement over delta t, the change in time. All right. So substituting, we get 10 meters minus 0 divided by 5 seconds minus 0. All right. So doing our math, we get the average velocity of the particle represented by graph line segment A, and that is equal to positive 2 meters per second. All right. This means that the particle is moving constantly at 2 meters per second in the forward direction. And with this as the average velocity for the first 5 seconds, all right, it is also correct to say that any instant or at any instant within the graph segment A, including at time equals 0, all right, we can safely say that the instantaneous velocity of the particle at time equals 0 is in fact equal to positive 2 meters per second, just equal to the average velocity within the time interval, all right, from 0 to 5 seconds. Continuing our calculation for average velocity, we have for segment B, all right? So segment B is a straight line sloping downward to the right. So again, our expected average velocity during this time interval, 5 seconds to 10 seconds, will be negative. And computing for that, the average velocity is just equal to the slope of the graph B, or delta V, which is final position minus initial position. All right? The final position is negative 5 meters, and the initial position is positive 10 meters. So delta D is equal to negative 5 meters minus 10 meters, and this will be divided by the time interval from 5 seconds to 10 seconds, or 10 seconds minus 5 seconds. All right? So doing our math, we will get the average velocity represented by graph line B equal to negative 3 meters per second. It means that the particle is moving at a constant velocity of 3 meters per second in the backward or opposite direction. Next, for graph line C. During the next 15 seconds, or from t equals 10 seconds to 25 seconds, we see that the graph line presented by segment C is a straight horizontal graph line. All right? This suggests that the slope of this horizontal graph line is just equal to 0. This means that the particle is stationary or motionless during that time interval. So we just emphasize that the average velocity, okay, represented by graph line C, is just equal to 0, or 0 meters per second. And lastly, for segment D, you will notice that segment D, all right, is again a straight graph line but sloping upward to the right, exactly the same as graph line A. So again, we can predict that the average velocity during this time interval, 25 seconds to 30 seconds, the body has a positive constant velocity, right? So computing for that, we get delta D minus, or the delta D is the final position minus the initial position, that is 0 minus negative 5 meters, right? 0 being the final position, and negative 5 being the initial position. All right, so that will be divided by the time interval, 5 seconds, or 30 seconds minus 25 seconds. So we will get as the average velocity during that time interval, represented by graph line or segment D. It's just equal to positive 1 meter per second. Right? Again, what does this mean? We say that in the last 5 seconds of its motion, the particle is in fact moving towards its point of origin with a constant velocity of positive 1 meter per second. Because, as shown in the graph, after 10 seconds, you will notice that after 10 seconds from the start, the particle, all right, has moved to a displacement negative 5 meters, all right? Negative 5 meters meaning um, relative to the origin, the particle is 5 meters, all right, in the opposite direction, 5 meters away from the origin, right? So that means during the last 5 seconds, the body is moving back, meaning it is heading back towards the origin. So, as expected, all right, we get a positive velocity, which is positive 1 meter per second. Now, we have a challenge question for you. All right, at exactly time equals 30 seconds, that means at that instant, 30 seconds, what do you think is the particle's instantaneous velocity? All right, if you know the answer, drop it in the comments section. Question letter B is asking for the total distance covered by the particle from time equals 0 to time equals 30 seconds. Since distance is a scalar quantity, so we just add the distances traveled by the particle for segments A, B, C, and D, all right, without considering the directions. And since segment C represents what we call a body that is stationary. In short, during this time interval, all right, represented by segment C, the particle is motionless, so it has not covered or traveled any distance. So, in our formula for total distance, we are just adding here the distances represented by segments A, B, and D. That is, the total distance for segment A is equal to 10 meters plus, all right, the distance represented by segment B is in fact 15 meters. Why? Because um, from 5 seconds to about 7.5 seconds, it has traveled 10 meters, all right? And then the second part of that segment from 7.5 or about 7.5 seconds to 10 seconds, it also has traveled 5 meters. So that's a total of 15 meters. And lastly, for segment D, that's equivalent to 5 meters. So for a total of 30 meters. That's the total distance covered during that time interval, 0 to 30 seconds. And for question letter C, we are asked to find the net displacement, all right, for the same time interval, 0 to 30 seconds. And since displacement is a vector quantity, we will be adding the individual displacements, all right, represented by, again, segment A, B, and D. That is, for segment A, that's positive 10 meters, all right? And then for segment B, that's a net displacement of negative 15. So we have here minus 15 meters. And lastly, for segment D, that is a displacement of positive 5 meters. So for a total of 0 net displacement. All right? We can also apply the shortcut formula for determining net displacement, which by definition is just equal to the final position, df, minus the initial position, di. All right? The final position, that's exactly at 30 seconds. The final position is, of course, 0, and the initial position at time equals 0 is also equal to 0. Therefore, our total displacement is 0, right? And it agrees with the first answer. It is as if, all right, it is as if that the particle has not been displaced at all. 0 net displacement simply implies that the body looks like it has not been displaced. All right, but as far as distance, total distance concerned, in fact, it has traveled 30 meters. So you see here the big difference between distance and displacement. All right. Again, um, we have a challenge question for you. Suppose you're asked, all right, from time equals 0 to time equals 30 seconds, what do you think is the average speed of the particle? And likewise, what is its average velocity? All right, the same time interval, t equals 0 to t equals 30 seconds. Calculate for the average speed and the average velocity. If you have the answers, drop them in the comments. So that's it, we're done. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.